This gets us into accessing our data, which is really where most of our effort is. We call this extract, transform, and load. And if you're dealing with data analysis, this right here is 90% of your work. Visualizations are really cool, but that's like after you've done all of the heavy lifting. Data analytics is not very exciting in this area. In fact, it's really tedious and obnoxious. But without doing this, you can't create interesting visualizations that will actually be compelling and move management to make decisions. We're going to go through this process of ETL. Basically, we have to define the scope of the data or the risk. We're going to obtain the data either from a data warehouse. So you go into your business, say, hey, I need access to the data so I can do analysis. Say, great, here's the login. Go have fun. If you're an auditor, that very rarely happens. You're going to request data from IT. And you say, hey, I'm doing an audit of the accounts receivable process. I need a list of all the customers and the sales transactions and the accounts receivable credit memos and the cash receipts. And I just say, great, I'll get right on that. And then they'll send you the wrong data. And you say, no, I need this data for this period. Please do it again. And you go with the back and forth. So a lot of this ETL process is actually soft skills. It's, buttering up the IT people so that they do it for you the first time. So you get the data that you need, or being very specific on what you need for that analysis. We're going to validate it, clean it up, and then load it into the process. So extracting, here are the steps. First thing you want to do is you want to start with the ER diagram or the database schema. What does ER stand for? Entity relationship, right? We're going to look at a map of all of the classes and relationships, the tables and so forth. We say, okay, we got a product, we got line items, sales, and customer. That's helpful. We know the cardinalities, how they're linked together. Number two, we are going to identify the tables and attributes that we need for our analysis. So let's say I have a question. My question is, which products are selling in various areas? So I want to see how products are doing in different geographic regions around me. So I say, okay, here I've got some information. So in order to find the areas, I need my zip code from my customer table. I have to figure out the product category from my product table. I'll probably need the date so that I can see when things are selling, not only what's selling, but in a time period like last month versus last year, which I'll get from my sales table. And if I'm trying to look at it in terms of dollars, I need my price and quantity from my line items. So I don't need all of the data, but I need these very specific fields in order to answer my question. I have to be able to look at this and say, okay, I need my category, my zip code, my date, my price and quantity. And then I have to combine them all together. While we're looking at this, we are going to refer to the data dictionary. Okay, the data dictionary tells us whether these attributes actually have what we want or not. So we haven't even looked at the data right at this point. We're just looking at where the data will be stored. So each of these lines represents an attribute. This is like the first screen that we were looking at in SQLite, where it showed you this is a text field versus a number field. So I've got my primary key, it's required, this is my customer ID, sequential number, so I know what type of data to expect when I'm extracting this. I know that it's text, so I can combine text with text and numbers with numbers. If I try and match incompatible data, it's not going to work, so I'll have to convert it. We're going to deal with all of this. Next, we are going to access the data, either with a warehouse or request data. And the data request is really fun because we're going to fill out a form, send an email to IT and say, hey, these are all the things that we need. Here's the scope, here are the dates that I need it for, here's the volume. You have to be very specific on the data that you want because you'll get exactly what you ask for. If you don't ask for it, you don't get it. You have to go back and forth. And they're going to send you the file in one of possibly four different formats, four common formats. They're going to give you an Excel file. No, they're not. Excel is an option, but nobody is going to export data as specifically an Excel formatted file. And the reason why is because Excel is limited. For small tables, sure, but transactions, you're going to hit that million row limit very quickly. So Excel is not the best tool for most of this analysis. Instead, what they're going to send is an extract, either in a comma separated value, a CSV. A comma separated value file is going to have each line represents a record, and they're going to have commas separating the values. So I have, ID and name and address. When you import this into whatever tool, they say whenever there's a comma, put it in a new column in your table. We have XML. XML stands for Extensible Markup Language. And the difference here is we are going to tag each of these values. So instead of putting all the values with a comma, I'm going to say, okay, I have an ID 1001 and an end tag with a /ID that says everything between these two tags is 1001. I have name, Teeter, name, address, Linden, address. So these files, XML files, are much larger than just CSV files because you have to repeat this for every single line item that's going to show up in there. But XML files are really useful if you are taking it from one computer program and loading it directly to another computer program, because a computer cannot get context into what is included in a column. They don't know what that means in the same sense as if it's tagged, they know exactly what that value is. So I can highlight name, and it's going to say anything that's tagged name is an important value. So XML is much more useful for analyzing within a computer program, but CSV is more useful for you to do like hands-on work. And then finally, we have a text file. This is usually a tab separated value file. So instead of commas, you use tabs, so ID, and then you got tab, name, tab, 1001, Teeter, and so forth. These are more old school, like older systems will use this. More modern systems will use XML. And in between, you'll have CSV. Everybody understands CSV, so that's probably the most common one that you're going to come across. By the way, CSV and text files, these are also called delimited. That just means that there's some sort of character in between them, whether it's a comma or a space or a tab or some other symbol to separate them out. Data file formats that we're working with. And then the last step, we are going to validate the data. So the way that we validate the data is we are going to do summary statistics. So we're going to calculate things like the sum and the count, maybe the average or minimum maximum. So we make sure that we have the same number of records that they sent us, that the total and the sales value matches the sales account balance, and so forth.